everyone, Mrs. Burry here. So here's our day 2 of notes in our new trigonometry unit, and this is probably my favorite thing to teach. You're going to learn about SOHCAHTOA today and right triangle trigonometry. So let's start off. This video will probably be a little long. I'm trying to keep them short. I'm just going to see how much time this takes, but I want you to be okay. So we're going to have an introduction to right triangle trigonometry. So we're starting with a right triangle. To use trigonometry, you always have to have a right triangle, and here's my examples here. So you must have a right triangle, and the angle in question, in this case we're calling it theta, that's the Greek symbol for theta, dictates how we come up with parts of the triangle, okay? With the Pythagorean theorem in the last lesson, we just used a leg, and hypotenuse. That's pretty easy to do. But now we're taking it another level. They're still legs, and that's still a hypotenuse, but we have to differentiate between the two legs. So this is how we do it. Our reference angle, or the angle we're looking from, we're calling it theta here, or angle A. I have to determine what side is opposite from my reference angle. So this is my reference angle, and I go across the triangle and I have an opposite side. We call it opposite, and sometimes we label it with just a capital letter O. Okay? We also have what's called an adjacent side. This is my reference angle. The word adjacent means next to. It means next to my reference angle and the right angle. So in between my reference angle and the right angle is called the adjacent side. And we can also call that a capital letter A, short for adjacent. Now see, just like in the Pythagorean theorem, across from the right angle we have our hypotenuse, and we can label that H, short for a hypotenuse. Okay? Now, in a right triangle, we can also look from the other angle. In this example here, we are looking from angle B, it's marked angle theta here, and going across the triangle from the angle, the opposite side is across. Going next to our reference angle, next to the reference angle, and next to the right angle is called adjacent. That's a capital A. And across from the right angle is the hypotenuse, and we can label that capital H. Okay? So we can look from either ends of the triangle, and it changes the O and A value. It doesn't change the hypotenuse. That's always across from the right angle. Okay? So we have to be careful about where we're looking from. Why do we care about labeling our triangle H, O, and A? It's because it gives us the trig ratios. Okay? Now, the most common way to remember trig ratios is SOH, CA, TOA. SO stands for sine. That's a trig function. C and CA stands for cosine. And T and TOA stands for tangent. Okay? Now, these are ratios or fractions created from two sides of the triangle. So, SOHCAHTOA, which I usually write like this. SO, S-O over H. CA is A over H. And TOA is T for tangent is O over H. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. Okay? So in this first part, so I'm talking about sine. And the sine of our reference angle would be calculated by taking the opposite side, the length of the opposite side, and putting it over the hypotenuse, or O over H. Okay? Cosine is created by taking the adjacent side over hypotenuse, so I would have the adjacent side over the hypotenuse, or A over H. The tangent ratio of a given angle would be calculated by doing the opposite side over the adjacent side. So it would be opposite side over adjacent side, or O over A. Okay? Those are the primary three trig functions. And then they're each related to a reciprocal trig function. Sine is a reciprocal with cosecant. Cosine is a reciprocal with secant. And tangent is a reciprocal with cotangent. And all that means is we flip the fraction over. So if I have sine and I need cosecant, I just flip it over. So instead of O over H, I'm going to have H over O. Cosine and secant are reciprocal trig functions. So cosine is a over h, so its reciprocal secant would be h over a. So we flipped it. Okay? And the last one, if tangent is o over a, its reciprocal is cotangent, and it would be found a over o. Okay? Now, on calculators, these are usually listed, and I'm going to show you my TI calculator, but many of you probably don't have this right now, but the way we can keep those reciprocal relationships together is if we go to our trig button on our calculator, which is right here, and you can see they're listed: sine, cosine, tangent, 1, 2, 3. And the other reciprocals are 1, 2, 3, cosecant, secant, cotangent. That helps us remember which one goes with which. Sine goes with cosecant, cosine goes with secant, and tan goes with cotangent. So we can keep those reciprocal relationships together. Now, we know you don't have a calculator, so I've adjusted this lesson, but I just wanted you to see that relationship here if you can use your calculator to help you. Okay? So let's go ahead and do a few of these. So what do we do? In our first example right here, we're going to find all 6 trig ratios based on this triangle. And it's saying use angle A as the reference or theta angle. So I'm going to locate angle A here, and that's my reference angle, okay? And I can label it theta. So I'm looking from this reference angle. So first let's find the hypotenuse. There's the right angle. Across from the right angle is the hypotenuse. Now, opposite side of our reference angle is the opposite side, and next to our reference angle is the adjacent side. So I have labeled the triangle O, A, and H. So now I have to find the 3 trig function, or the all 6 trig functions. So how am I going to do that? I'm going to use SOHCAHTOA. So is S-O-H. Ka, I always say it like really funny with the A. C is adjacent over hypotenuse, AH. And TOA, T-O-A. That gives us our fractions we build for sine, cosine, and tangent. So let's do it. So the sine of our reference angle theta is made by doing O over H. O is 7, H is 15, so that's going to be 7 over 15. Cosine of our reference angle is just a fraction, and the cosine is made by doing A over H. A is 8, H is 15, so it's going to be 8 over 15. Okay? And the tangent of our reference angle, looking at SOHCAHTOA, tangent is created by O over A. So that's going to be 7 over 8. Okay? Now we need the reciprocal identities. They would be cosecant goes with sine, and you just flip it, 15 over 7. Cosine is a reciprocal with secant. Flip the fraction, 15 over 8. Cotangent is the reciprocal function with tangent. Instead of 7 over 8, we're going to have 8 over 7. So we found all 6 trig functions of this triangle given. Let's do the other one right here. So now, in this example, notice how we have sides 7, 8, and 15 here. I also have sides 7, 8, and 15 here, but it's asking me to use angle B this time. So angle B gets labeled as my reference angle. So here's B here. This is my angle theta, and I'm looking from there, and I'm going to label the triangle. Find the hypotenuse, which is across from the right angle. That's H. Across from our reference angle, this is our opposite side. And next to our reference angle is our adjacent side. So I have HOA. Okay? So sine of our reference angle. Sine is created. Now I still have SOHCAHTOA written up here. Sine is made by O over H. That's going to be 8 over 15. Cosine of our angle is A over H. That's going to be 7 over 15. And tangent of our reference angle is, tangent is formed by O over A, 8 over 7. Okay? And then the reciprocal reciprocal functions would be cosecant, flip sine, secant, flip cosine, and cotangent, flip tangent. And that's it. So those are your first two examples of the trig functions using the different reference angles. Now, the other thing that we can ask you to do here is, they're going to give you a right triangle. I have sides 6 and 10, but you need to find this side before you can do the trig functions, so it's a two-part question. So the first thing we're going to have to do is find this missing side. I'm going to go ahead and call it x right now, okay? Now, first part is use the Pythagorean theorem to find the missing side. Now the missing side is a leg, this is a leg, this is a leg, and this is hypotenuse. I'm going to go ahead and label the hypotenuse now. Now, the Pythagorean theorem was a squared plus b squared equals c squared. Leg squared plus leg squared equals hypotenuse squared. So the legs would be, one of them 6, call that and square that. The other one's the missing side, x squared, and the hypotenuse is 10. Okay, so 6 squared is 36, and 10 squared is 100. Okay, and so minus 36 and 100 minus 36 is 64. And I have x squared equals 64. I'm going to take the square root of both of those. The square root of 64 comes out to an even 8. Right? So our missing side here has length 8. And now we can go ahead and get our trig functions because we have all 3 sides of the right triangle. So we're going to go ahead and go right into those. All right, the first one is sine. First of all, here, locate your reference angle. There's my reference angle. Label your hypotenuse, which is labeled here. And across from the reference angle is side O for opposite. And next to the reference angle is A for adjacent. Okay, so I have H, O, and A labeled. I'm going to use SOHCAHTOA. SOHCAHTOA. So the sine of my reference angle is O over H. That's 6 over 10. And we will reduce that fraction. 6 over 10 reduces to 3 over 5. Cosine of our reference angle, cosine is made by A over H. That would be 8 over 10. And reduce that fraction. That reduces to 4 over 5. And then the last one we have to do is tangent. The tangent is created by opposite over adjacent. So that's going to be 6 over 8. And reduce that fraction to 3 over 4. Now, these are my final answers: sine, cosine, and tangent. And to get the other 6 trig functions, I'm just going to flip those. So cosecant of theta is a flip of sine, 5 over 3. Secant of theta goes with cosine. Flip this, 5 over 4. And cotangent of theta is flip tangent, 4 over 3. So these are my remaining 3 trig functions that go with that. Okay? So that's how that works. So we had to use the Pythagorean theorem to find the missing side, and then we went ahead and filled out our trig functions. Our last example here does have a little extra step to it. And I don't know if you've had it already this year, so I'm going to take it kind of slow. So on this one, the first thing we have to do is find our reference angle. There it is right there. I'm getting a little ahead of myself. Let's go ahead and find this missing side. We don't have anything for this side here. I'm going to label it X. So the first thing I have to do is use the Pythagorean theorem to find the missing side. Now, this missing side is across from the right angle, so that's our hypotenuse, okay? So the 13 is a leg and the 4 is a leg. So this would be leg squared, that's 13 squared, plus the other leg, 4 squared, equals the hypotenuse squared, okay? 13 squared is 169, 4 squared is 16, and the x squared's right there. 185, when you add those two together, equals x squared. Now, I got to take the square root of both of those. So, x equals the square root of 185. Now, I went ahead and factored 185 for us. 185 factored as 5 times 37, so there's no simplification to do there, okay? Now let's go right into our trig functions, okay? So we have SOHCAHTOA again. SOHCAHTOA, okay? So the sine of our reference angle is O over H. Oops, I didn't label these yet. Let's go ahead and label it. Here's my reference angle. The hypotenuse we found already. Across from the reference angle is labeled O for opposite the reference angle. And next to the reference angle, between the reference angle and the right angle, is our adjacent side. Now I can go ahead and do those trig functions. So the sine of our angle is O over H, which would give us 4 over, and I'm going to go ahead and fill in this x here, 185 square root. Okay. So O is 4 over rad 185. Now, this is where we get to a step. I don't know if you've had this already this year, so I'm going to take it slow. We cannot leave an answer with a radical in the denominator, and here's how we fix it. It's called rationalizing the denominator. When you end up with a radical in the denominator, to get rid of it, you multiply the top and the bottom by that radical. Okay? So, the sine of theta, rad 185 times rad 185. The radical goes away and you keep what's inside. So the denominator becomes just plain old 185 without the radical on it. And the top becomes 4 times rad 185, and there's nothing to simplify there. Okay? So if they asked you for a decimal, you would just key that in and get the decimal. So the cosine of our angle, the cosine is formed by A over H. That's going to be 13 over rad 185. Okay, there's that radical in our denominator again. To get rid of it, we multiply top and bottom by that radical. So the top here becomes 13 times rad 185. And again, in the bottom, a rad times a rad, you multiply, the guts are the same, or the insides are the same, so the rad goes away and you're left with just the number that's inside. All right, now we did sine, cosine, we need to do tangent. Tangent is formed by O over A. That would be 4 over 13. And we don't have to do the extra step there. All right, so now these are my final answers: the sine, the cosine, and the tangent. And they allow me to get the reciprocal. So reciprocal with sine is cosecant. And I'm going to flip that. Now, I'm going to make this easier on myself. Instead of flipping this and putting the rad 185 in the bottom again, I'm going to go back to my original function and flip that. So that means the rad 185 goes on the top and the 4 goes on the bottom for cosecant. So rad 185 over 4. And that's nice because there's nothing else to do from that. Okay? I'm going to do the same with secant. Secant is the flip of cosine. So the original cosine function I got was 13 over rad 185. I'm going to flip that. And I have nothing else to do because there's no radical in my denominator. And the last one, tangent, is reciprocal with cotangent. Flip that, that's 13 over 4. And those are my other reciprocal trig functions. So that works pretty good. Okay, and in your Delta Math, sometimes they ask for decimal and sometimes they ask for a fraction. So I'm going to show you an example of how they ask the questions on Delta Math, because you're going to go over there and do some practice problems. So here's an example how they ask you on Delta Math. It's not like the ones we did in class, but they're telling you in a triangle MNO, now we know these are trig, so we know that we're going to have a right triangle. So let's draw a right triangle. Okay, its vertices are going to be M, N, and O. And it says the measure of angle O is 90 degrees. That's your right angle. So angle O should be labeling on the right angle part. It is very important that you label these correct. Okay? Now, they're saying that side MO is 36. Now, M and N aren't labeled, so I'm going to have to just label those. Those are the ends of the legs here from the right angle, so it doesn't really matter. I'm going to go ahead and do M, N, O. So label it first and then label the sides. MO is 36, NM is 85, and ON is 77. So you want to make sure you label that right, because if you don't label it right, your answer isn't going to make any sense. All right, now what ratio represents the tangent of angle M? So angle M is my reference angle. That's where I look from. So across from the right angle is the hypotenuse. Opposite my reference angle, which is M, is my O side, my opposite side. And next to my reference angle in the right angle is my adjacent side. So I have HOA labeled. And they're asking me for tangent. So the tangent of M can be found by doing SOHCAHTOA. SOHCAHTOA. Should be on the top of all your papers when you're doing this. Tangent is found by doing O over A, so that would be 77 over 36. Okay? And so the answer here is they're going to ask you to type 77 over 36 because they're saying what ratio. Sometimes they say get the decimal. It just means divide 77 by 36 and get the decimal and round it off as the instructions say. All right? So on the next 2 pages, there's some more practice problems. I will post the answers for those. And then on Delta Math, I gave you 5 problems to work on, and you'll get unlimited tries on those. And some of those are decimals, so just be careful with that. So sometimes we want you to enter a fraction, and sometimes the decimals. And I'm going to cut this video off here. I thought it would be a little long, but it's I thought it was necessary, so I'll make the next one shorter for sure. So I hope you all are doing well, and I miss you very much. I'll talk to you soon.